Hi, this is Sami again. As I promised, I will finish this final exam. This has trig all over it. So the remaining of the final exam here is just trig. About 5 more or 6 more trig questions. I think some of them involve a little bit of identities. One is identity all the way. Stay tuned. I'm going to start doing this. There we go. So this question basically solved between -2 pi and 0. So they want you to find all the angles between -2 pi and 0 that satisfy this equation right here. What's wrong with this equation? What's wrong with this equation is we have two variables or two different sinusoidal functions, sine and cos. When we see something like this, the first thing we think of is, oh, we're going to factor this. But this has to be cos squared for us to be able to factor. So what can we do here? Now, as I said, identities. So that sine squared, I could express it as 1 minus cos squared theta. And let me tell you something. This identity, you shouldn't be looking it up when you're writing tests or exams with trigonometry. The first identity, the sine squared plus cos squared, and how it's manipulated, you should know that by heart, because you don't want to slow down writing the test. You know, your process of thinking slows down when you don't remember some of this stuff. So sine squared is 1 minus cos squared, and now plus 3 cos theta equals 3. So from here, what we're going to do, we're going to distribute the 2n, so we get 2 minus 2 cos squared theta plus 3 cos theta equals 3. I'm going to move everything to the right side to get rid of the negative in front of the cos squared. So now I'm going to have 0 equals 2 cos squared theta minus 3 cos theta, because you're moving things to the other side of the equal sign, plus 1. Because when you move this 2 to the other side, it becomes minus 2. 3 minus 2 is 1. Now, we're going to factor this. 2 times 1 is 2. What multiplies to 2 and add to give you -3 is -2 and -1. So this will factor into. So cos theta minus 2 and cos theta minus 1. And then I'm going to divide both by 2 since we have a 2 right here. And this will give me cos theta minus 1 equals 0. And 2 cos theta minus 1. Now, the solution would be cos theta equals 1 from here, and cos theta equals 1/2. Now, to find theta, for the 1, you're going to look at the cosine wave. Must remember the cosine wave, because you do graphing on this kind of exams or tests, and you need to remember the cos wave. So 1 pi over 2 pi, 2 pi, 3 pi over 2, 2 pi right here. And since it's between -2 pi and 0, we should be looking on this side, sorry. So the graph continues that way. And so here's -2 pi. And so between 0 and -2 pi, it equals 1 right here, right? 1. So the theta equals 0. I'm just going to write that a little bit down here. Theta equals 0 and 2 pi, because that's where -2 pi, sorry. That is where cos theta equals 1, as we see here. It's at 0 and at -2 pi, since this is the domain. Now, how about for the other? Cos theta equals 1/2. Cos theta equals 1/2. Cos is positive right here and right there. So all students take calculus. 0, pi, 2 pi. You know, when I'm finding these angles and this kind of questions, I don't even bother writing the pi over 2 and the 3 pi over 2, because we never use them to find what the angle is, because we always referring to pi or 2 pi or 0. We never refer to pi over 2 or 3 pi over 2. So now the angle that has a cos of a half is the 60 degrees, or pi over 3. So it's pi over 3 here and there. If you don't remember your special angle triangles, 30, 60, that is 1 root 3, 2. So as you see, cos 60 is 1/2. So therefore, your reference angle is 60, except it is in radians, so it's pi over 3. The 60 is pi over 3. So therefore, your first angle here is theta equals pi over 3, because that is what that is. And then the other theta, or theta 2, if you want to call it, you go all the way to 2 pi, because you're measuring from the 0 all the way to here. So you go all the way to 2 pi and take away the pi over 3. So that's the same as 6 pi minus pi, because the common denominator is 3. So that makes it 6 over 3. So therefore, it's 5 pi over 3. And that is one of your answers. That is the other one. And these two right here. So 0, negative 2 pi, and pi over 3 and 5 pi over 3. These are the answers for this question. Okay, so let's move on to the next question. Here's the other one. The thing with this one is it is written in factorable form. That's a trinomial, quadratic. So definitely, when you factor this, you write sine x in one bracket, sine x, and the other bracket equals 0. Now, what multiplies to give you 6 and adds to give you 5? So 6 times 1. Just the earlier one, I went through the factoring really fast, but maybe I'll slow down so you see what I'm doing. Now, what multiplies to give you 6 and add to give you 5? It is plus 3 plus 2. When you do that, it doesn't stop here for me, because this, when you have a leading coefficient, whatever you find here, you have to divide by it. So you have to divide this by 6, and this is by 6. Now this will give you sine x plus 1/2 and sine x plus 1/3 equals 0. So sine x equals negative 1/2. I'm not even going to put the 2 in front of there, because I see what the sine x is going to be easier from here. Now, let's take the sine x equals negative 1/2 first. Of course, you draw your quadrants, 0, pi, 2 pi. The sine is negative right here and right there. The angle that has a sine of a half is the 30 degrees, which is pi over 6 here and there. That's your reference angle. So this one here, you go all the way to pi and add the pi over 6. And the second one, you go all the way to 2 pi and take away the pi over 6. So x1 equals pi minus pi over 6. And x2 equals 2 pi. Sorry, that's plus pi over 6. We go all the way to pi and add the pi over 6. 2 pi minus pi over 6. Now this is 6 pi over 6. If you do in common denominator, plus pi over 6 is 7 pi over 6. And this one here, if you make in common denominator 6, it'll be read 12 over 6. 12 over 6 minus 1 pi over 6 is 11 pi over 6. So these are the two answers, and we need to find the answers from sine x equals the negative 1/3. This here is not a special angle. So what you gotta do, you gotta resort to your calculator. And when I say resort to your calculator, you're just gonna still write 0, 2 pi here, pi there, the cosine is negative here and there. Now what you do, you go to your calculator. Make sure when you go to calculator, because this is between 0 and 2 pi, your calculator must be set in radians mode. So you set your calculator in Radians mode. That's the first thing you do. Mode. And then you go in your calculator, you go second sine. When you put the number in your calculator, when you go second sine, don't put in the negative. That negative just indicates that you're in the third and the fourth quadrant. All students take calculus. Okay, so you don't throw in the negative in your calculator, so just 1 divided by 3, and that would give you a reference angle of 0.34. So here is 0.34, 0.34. You cannot express this in exact value, so x3, if you wish, would equal pi plus 0.34, and x4 would equal 2 pi, take away 0.34. Okay, so plus pi so this one will be 3.48, and this one here, so that is my third answer, and this will be 2 pi minus 0.34 equals 5.94. So this one will be 5.94. And now all of these are your answer, all the circled ones right there. And this is done. Let's move on to the next question. So here what they asking me the question to graph both of these. Okay. And then the second part of the question, do you believe this demonstrates an identity? So if it's an identity, that means this here should equal this. And if they're equal, then they must overlap. So they'll give you the same graph. So let's look at sine 2x first. So I'm going to graph y equals sine 2x using the blue. And then I'll use a different color to graph that one. The only thing here that changed is the period. Everything else is the same. So the period is 2 pi over b, and b is 2 there. So that gives me pi. My scale, always a multiply the period by 1/4. So the scale is pi over 4. So what you do, when you make a pi right here, just make sure you divide it into 4 segments. That's what it means, scaling pi over 4. So that's pi over 2, that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And then I'm going to do the same thing on this side, negative pi, and then just negative pi over 2. And I'm just going to put 1 right here and 1 right there. It doesn't seem like there is any higher amplitude than 1. So 1 and negative 1. Now, if the period is pi, the sine graph starts at 0. But instead of finishing at 2 pi, it's going to finish at pi. In the middle here is going to be at pi over 2. Because always the middle is always between the start and the beginning. And then here you're going to have a max. And between here, you're going to have a min. So your max there is at pi over 4, and your min is at 3 pi over 4. Remember this scale by pi over 4, 2 pi over 4, 3 pi over 4, and so on, negative pi over 4 if you wish. All right. So this part of the graph looks like this. This is an easier graph than the last one, this one right here. So now let's just change colors, and I'm going to graph the other one, y equals negative cos 2 brackets x plus pi over 4, close bracket, close bracket. Now here what we have, the period is the same thing. There's pi because it's 2 pi divided by b, and b here is 2. Yeah. This also reflected over the x-axis, yeah, over x, and then shifted pi over 4 to the left. So now let's just graph a cosine function. as if the period was pi instead. So the cosine, if you remember, started at a max when it was at a max with 2 pi, but now the period is pi. So let's just graph a cosine function that has a period of pi. So it should finish here. The minimum should be here. And then this is my quarter point right there and right there. Okay, so these are the points here for full period without reflecting and over pi over 4. So what I'm going to do, I'm going to take each point now, reflect it right there and move it pi over 4. I'm just going to use x so I don't get confused with my points here. So that's done. Now this reflects over the x-axis, nothing, because it's right on the x-axis and shifts pi over 4 to the left. So I'm going to do this. And then this reflects over the x-axis and then pi over 4 to the left. So it goes right there. So it's an x. And now this nothing, but then moves left pi over 4 to the left right there. And then this goes right there and then shifts pi over 4 to the left. So it goes right there. So these are my new points. And as you see, what happens, these graphs overlap. Okay, so basically it's going over the other graph and, you know, continue that way. So since they overlap, then answering this question right here, yes, it is an identity. So anytime the graphs overlap, you know, both graphs give you the same graph. So you could prove them to be equal. And you could do that even algebraically, but we're not going to go to that right now. Okay. So there we go, prove this identity. This identity, so they always give you an identity sheet. So here, what you do is you do left side, right side kind of thing. So the left side, the 2 sine x, there's nothing that you could do there. But the sine 2x, you could change that to 2 sine x. Cos x. Honestly, I think this is like 2 marks giveaway. So you should be really happy to see a question like this on the test. Your identity sheet is right on is given to you. So now once you do this, 2 and 2 reduces, sine x and sine x reduces. The common mistake I see students do through my experience, that they write the answer for this as cos x. No, it's not. Cos x is in the bottom of the fraction. It cannot just go on to the top. You have 1 left on top right here. So that's 1 over cos x. And 1 over cos x is the same as secant x. And you should memorize that. You shouldn't be looking that up. If you're looking at that up in the final exam, that means you have cramped for the exam or something and you didn't remember your some of your identities. You have to remember, like you should remember that cotangent equals 1 over tan and cos also equals cos over sine, secant is 1 over cos and so on. Okay, so therefore secant equals secant x, proven. How about here? Here is a question that's interesting. Now see cos 2 theta plus 2 sine squared theta equals 1. Again, this looks like I have to factor, but I have cos here and I have sine squared. This is a single angle, this is a double angle. I cannot do it unless I make some changes. Cos 2 theta, you have 3 choices for cos 2 theta. So you know how it is, cos squared minus sine squared, 2 cos squared minus 1, or 1 minus 2 sine squared. Definitely you want to choose for cos 2 theta, 1 minus 2 sine squared theta. That's exactly what you want to choose for that one. Plus 2 sine squared theta equals 1. Wow, look at that. So cos 2 theta, it made me even doubt myself that I remember. So I'm just going to look that up again. Caught me by surprise. Yeah, 1 minus 2 sine squared theta. So now you see here, this will cancel. You'll end up with 1 equals 1. And that's true, 1 equals 1. When that's true, then you know this has infinite or infinitely many, there's a y, solutions. That anytime you end up with a number equaling a number and it's true, this is what your answer is. Let's say you ended up with 0 equaling 5 or something like that, or 0 equals 1, when it's not true, then you say no solution. But in here, infinitely many solutions. Okay, infinitely, where's the rest of infinitely? Infinitely, yeah, there you go. Many solutions. All right. Think one more. Hey, last question. Thank God. So this question here, they say find the exact value. Now you look at this and you say 80, 55. What do you mean exact value? There's no exact value to 80 and 55 because we don't have a special angle triangles that are 80, 55. However, there must be something that we could do here. What we could do, we go and look at our identity sheet. And our identity sheet has the tan alpha plus beta. If you look that up, it gives you it's tan alpha plus tan beta over 1 minus tan alpha tan beta. So here's, I'm going to write the identity right on top here. Okay, so give me 1 second here. Tan alpha plus beta gives you tan alpha minus tan beta over 1 minus tan alpha tan beta. You know, as ugly as this looks and as complicated as it looks, it's not really complicated. So what you're doing here, they're giving you this form right here, and they want you to go back to this form right there. So think of the 80 is alpha and the 55 is beta. So written exactly in this form. If you want to change it to that, all you need to do is just say, okay, this is tan alpha, which is 80, plus beta, which is 55. And that will give me tan 135. Now this is a special angle. It's not special angle. It is special angle, but you won't be able to see it till you draw it on your x-axis, y-axis. 0, pi, 2 pi. Or you know what? Since it's degrees, why am I using pi and 2 pi? Let's use 180. And 0 to 360, 90 to 70. 135 will happen to be right here. You don't have to be accurate how far you go as long as you're in the right quadrant. 135 is between 90 and 180, so that's 135. Drop a vertical. The reference angle here is 45, and that's exactly what you need to work with, so that will be 45. Therefore, this is 1, this is -1, this is √2. That's the 45-degree triangle. And tan would be opposite over adjacent, which is 1 over -1, which equals -1. Yay, we're done. This is it for this exam. So thank you for watching. This is it for this final exam. Till next time, thank you for watching again. Keep up the good work. Make sure you go ahead and subscribe to my channel, put a like, and share with others so they could benefit. Bye-bye for now.